Okay, fine guys, let's start. So where were we? In morning class, fine. So we are trying to understand this concept called as what SklearnPipelines. Pipelines. Agree? So yeah. So we started understanding something called as SklearnPipelines. Pipelines. So just to give a recap, so what are these pipelines? Okay. So before that, we studied something called as column transformer. So what is this column transformer? See, let's say you are having something called as imputer. Okay, given a data set, let's say you need to do imputer. That means what, filling the missing values. And let's say you need to do some encoding. Okay, in this encoding also you have some ordinal or one hot encoding, etc, etc. So instead of doing these individually for each column, so what we have done, we have created something, we have what we say, imported something called as column transformer, and we just passed everything to that column transformer. Fine. So it is just a wrapper around this. Fine. Instead of doing them individually, we are doing it in one shot. Agree? So similarly, now using the same idea, SklearnPipelines. So these pipelines are just an extension of this idea. That means we have seen a toy data set ML flow end to end, right? So over there, we have seen multiple things. Fine. So we have seen basic pre-processing, and we have seen scaling. Okay. And there we can also use these concepts like missing values, okay, encodings, fine. And all these things, you can, instead of doing them individually, you can put them in something called as SklearnPipeline. Okay, put them into a pipeline and just pickle this pipeline. Okay, instead of pickling. So in morning example, we are pickling three individual things. One is model we are pickling, and two one hot encodings we are pickling. Agree? So instead of pickling these three and again loading these three back, okay, here you can just put them everything into one thing called as SklearnPipeline, and you just need to pickle only this one thing. Okay, and just pass an input to this and it will give you the output. Fine. It is just an evolution of the previous thing. That means it combining multiple things into one thing and putting them in the pipeline. Okay, so that it will act as a wrapper around those things. Okay, fine. So now let's try to see with an example. So just to give a recap, in the morning we have seen this Titanic example without the pipeline. Okay, that means what we have done, all this imputing, okay, imputing and one hot encoding individually, and the model we have imported decision tree classifier, and this is accuracy score. And here if you see, we have imported, sorry, we have pickled three different things. One is the model, and there are two one hot encodings. Cool. And once we have done that, now for the same notebook, if you see the prediction, okay, because there will be two things, right guys? So it's called, one is development. Okay, second thing will be the prediction. Okay, it's usually called as inference, guys. This is usually called as inference. Okay, so usually practically in the companies it's called inference. So you will have two pipelines. One is development pipeline, okay, where you develop the things, build the models, etc. That is one thing. Okay, and the other thing is inference. Okay, inference pipeline. Okay, where you will try to infer or use the model and get some predictions. Cool. So this, for this inference pipeline, so if you see here, so what we need to do, we are loading back all those three things, the model, okay, this is the model, and two one hot encodings, and this is your input. Okay, and this input, okay, this input, what we are doing is we are passing through the same one hot encodings. Okay, what we have used it for the training data. Fine. So what are those? One is sex transform, and second thing is the embark transform. Okay, these two importings we have done, and we have concatenated. Okay, and finally whatever the input you are getting, that we are passing it to the model. Okay, this is the output. Okay, so all these things you need to do manually. Okay, and so that you can transform the data and get the prediction. Okay, so any doubts guys till this point? It's just a recap, but still any doubts? Are we good till this point?
Yes, Santosh.
Okay, so now if you see, using same thing, if you want to do using the pipeline, so how does it look? So if you see here, what we are trying to do on the same train data set. Okay, this is the data set, and we are dropping few columns, and finally we are doing the train test split. Okay, my y column is survived column, okay, prediction column, and remaining everything is my what, x column. And this is the first step, train test split is done. Okay, and as you can see, these are my input columns. Okay, and these are my output samples. Okay, zeros and ones. Now if you see, I am just creating certain transforms. Okay, so first of all, I need to do some imputations. That means fill up the missing values. Okay, so I'll just put these two side by side so that we'll have a comparison angle. Okay, so this, just try to focus whenever I'm switching, right? Focus on this heading. Okay, this is without using pipeline. So when we are without using pipeline, so what all the imputations we have done? So here I'm doing the same thing. So just I'm creating it as a transformers. Okay, no, I mean you are using column transformer. Okay, so if you see here, earlier we have understood one single column transformer, right? In the previous class, we understood one single column transformer. So here the point is to use multiple column transformer. Here for once, see, this is one single column transformer. This is used for imputation purpose. Okay, for imputation purpose. Agree? So this is simple imputer. Okay, and this is for age and this is for embarked. Fine. Second thing is for encode. Again column transform, but this column transformer is for one hot encoding. Okay, and this one hot encoding is for which column? Can you see here 1 and 6 columns? Okay, that means what? So this 1 in the sense 6 and 0, 1, 2, 3, 4, 5, 6 embark. Okay, these two columns are categorical columns. So I want to apply one hot encoding on these two columns. So that's why I'm saying apply one hot encoding on 1 and 6 columns. Okay, and that is one more column transformer. Okay, I'm giving the name as TRF2. Okay, and also I want to scale. Okay, I'm doing the scaling. Okay, so I'm using the min-max scaler, which we have already seen. Okay, so for that I'm using TRF3. And let's say you're also doing feature selection. Okay, we are not discussing feature selection, but we'll see it in future classes. But still, you can also put that as a one more transformer. Okay, and after that, the model, whatever the model you are having, right, that also you can use it as one more function. Okay, I'm saying it as TRF5. Okay, so all this TRF 1, 2, 3, 4, 5, earlier we have done it individually, right? So earlier we have done individually. Okay, and you need to take care of each and everything, okay, manually. But here what we are doing, so I have created this 5. Okay, I've created this 5. Now using this 5, okay, TRF 1, 2, 3, 4, 5. 1 is for imputer, 2 is for column transformer, 3 is for feature selection, 5 is for the model. Okay, I'm just putting them in something called as pipeline, guys. Focus this pipeline. Fine. So from where I'm getting this pipeline? So it is from the sklearn. So if you see here from sklearn pipeline, okay, from sklearn pipeline, I'm importing two things. One is pipeline and one is make pipeline. Okay. Apart from that, I think you are aware of everything. You know, train test split, you know, column transformer, you know, simple imputer. Okay, and one hot encoder, I mean max scaler. Okay, feature selection we did not cover. Okay, just you can ignore this. And eccentric classifier also, this is a model. We are yet to cover the models. Okay, but mainly focus on this row number 6, line 6. Okay, this is the way how you can import pipeline, sklearn.pipeline, import pipeline and make pipeline. Okay, and also just to mention, right, so as you know, Python is case sensitive. So it's a small trick to know whenever you're importing, right? So from module, these modules will always be in the smaller case. Okay, as you can see, sklearn pipeline, but the actual sorry, this library will be in the small case. Okay, but the actual module which you are importing, right, the pipeline, that will be in the, most of the time that will be in the camel case. Okay, as you can see, this all this model selection, compose, impute, everything in the small case. Agree? But what you are actually importing most of the times, okay, see here, column transformer, it is in camel case, simple imputer camel case, one hot encoding, min max scaler, pipeline, select k based, decision tree classifier, all these are in the camel case. Okay, as this is case sensitive, this is also important. Okay, fine. So coming back, this is how you can import the pipeline. Okay, after that, I'm just putting inside the pipeline, I'm putting all this 5. That's it. Okay, I'm putting all this TRF 1, 2, 3, 4, 5 into this pipeline, and this is my pipe. Now pipe is my complete end-to-end flow of my data set, complete ML flow. This pipe, this one single variable is having my whole ML flow. Now, just to mention, there are two things actually. So as you can see, sklearn is providing us two things. One is pipeline and also something called as make pipeline. Okay, both of these, okay, gives you the same result, but there is a small difference. Okay, the way how you give the input. Okay, nothing different, nothing difficult to understand. But here, pipeline requires naming of steps, while make pipeline does not require anything of that sort. Okay, what? So you can also use pipeline, or you can also use make pipeline. But the only difference is when you use pipeline, you can also give names like what is this what is the name of this TRF1, TRF2, like that. But for alternate syntaxes, if you don't want to use pipeline, you can just use make pipeline. Okay, you can just pass them as a parameters. You don't need to mention any names. Okay, you can use any both of them. Both of them will create pipelines. Okay, pipelines in the sense what, guys? So different steps you are combining into one thing and calling them as a pipeline. Okay, so that the flow continues. Okay, similar to water pipeline. Fine. Even in our house also, let's say you have syntax on top. So from there it will come. It will collect to, let's say, your bedroom, and from there it will go to your outside. Okay, somewhere. So that the continuity will not miss. Right. It's exactly the same concept. Right. Fine. So from first initial, the data should pass through this imputer. After that, the encoding will happen. From there, scaling will happen. From there, the model will get triggered. Okay. So the continuity, the flow should not miss. Agree? So this is how you can import and pass all the functions which you want to do as in parameters for this pipeline. Okay. So I'll stop here. Let me know, are we good? Any doubts? Are you guys on track?
Yes, sir.
Yes. Okay. So now, once this pipeline is done, so what we are doing, simple. So we need to fit it. So this pipe, see here, this pipe, I'm fitting it on train data and test data. Sorry, I mean train data, X-train and Y-train. Okay, from where we got this. Okay, here we got train data. So you are just creating all the what all column transformers you want to do. Okay, that I'm doing, and creating. Okay, I'm using this. I'm creating this pipe called as pipeline, and then I'm fitting it on my X-train, Y-train. Okay, so that's it. Nothing fancy. Okay, so once you do this, okay, once you do this, what happens? This pipe is consisting everything that we have mentioned. Okay, so this pipe is consisting in everything that we have discussed. So now if you see the pipe here, it is telling in detail. Okay, inside this you are having TRF1, TRF2, 3, 4, 5. Fine. So in TRF1, okay, in TRF1, what it is, it's a column transformer and it is imputing. Okay, there are two imputers, one is for age and one is for the embarked imputer, and second column transformer is for the 6 and embarked, okay, transformer. Okay, and third is for this min-max scaling, and fourth is for the feature selection, and fifth is for the decision tree classifier. Okay, all these are present inside our pipeline. Okay, and this, if you just print it, okay, it is just showing inside what all you are having inside your pipeline. Okay, and that's it, guys. Okay, so you don't need to do anything much. Just create what all the column transformers you want to create and just pass them as a parameters to the pipeline. Okay, and that's it. And these are just, if you want to understand more about the pipeline, these are the steps. Like if you say pipe, now pipe is my pipeline, right? So pipe is my variable. So over there you have multiple methods. That means if you say pipe dots named steps, okay, what all the steps that are involved in this, so it will give you in detail manner along with the names. Okay, and now if you want to do any prediction, this is the most easiest and interesting thing. Okay, so you can just pass your test data. Okay, you can just pass your test data to this pipe dot predict. Okay, see, understand, we are not doing clf dot predict. Okay, so this is a new thing as far as we have seen. Okay, usually we will do predict for what? For model. Agree? So usually wherever you see CLF is my model, decision tree classifier. Okay, on that you are using the predict method. Okay, but since we are putting everything in a pipeline, so okay, this pipe also you can use predict. Okay, so I'm saying pipe dot predict and passing my xtest, and my output is my ypred. Agree? And same story repeat. You already have y corresponding y test for this ypred, and you want to pass this, you will have the accuracy score. Okay, the same thing, nothing different. Okay, and there is something cross validation. Okay, and grid search CV. Okay, these are new concepts. Okay, so I'm not going into this. Okay, because it will be a bit lengthy and you might get confused. But once we cover this, okay, cross validation and grid search CV, I will come back, or I will take new different data sets and I'll let you know. Okay, but the main agenda of here is for you to understand how to create the pipeline and how to pass the different column transformers and create a one single pipeline. Is it clear, guys?
Yes, Santosh.
Yes. Okay. So now this is what till now what we have done. We have done this part. We have done what development part. Okay. We have developed the script. Now the second important thing is inference, because if you don't infer, that means if you don't use it for predictions, what is the point? So for that, if you see, so earlier we have seen a data set without using pipeline and prediction without using pipeline. Okay. Now just now we have seen Titanic with using pipeline, like how to create pipeline, and now we will also see prediction with using pipeline. See how simple it is. You don't need to do anything. So earlier, while you are creating the pipeline, okay, as I said, you just need to pickle only that pipeline, nothing else. Okay. Earlier, what you need to pickle without using pipeline, you need to pickle all these three things. If you have more encodings or more imputations, you need to pickle all those. And while loading also, you need to load all this. But the beauty of this pipeline is just you are creating everything in one pipe, and you just need to pickle only this. Pickle.dump, just pickle only this as a pickling object. And while predictions also, you just need to load only that. Okay, pickle.load pipe.pickle. Okay. And after that, you just need to pass your input, just like how you passed. Okay, if I prediction without using pipeline. Okay, so now without using pipeline, how you passed. Okay, in the same way, you are also doing the same thing. But earlier, all this heavy lifting, you need to do it manually. Agree? So for all these encodings, you need to pass them and take the input and pass them and take the unconcatenate. All this heavy lifting you need to do. Okay, but here you don't need to do anything, because this whatever the pipe you have pickled and loaded, right? So this particular pipe is having all these things. Okay, see where it is. If I ask for the yeah, so if you explore, right, so all these are already available inside the pipe. Okay, so you just need to pickle that, take this pipe, and you take any of your input, test input, and you're just passing this test input as an input to this pipe. So this pipe dot predict bus, so it is giving you the output. Agree? It is giving you the output. It is that simple. You don't need to worry about what encodings you have done, what imputations you have done, nothing. Okay, only during the development time, you need to take care of that and put everything in one pipeline. Okay, and just pickle that, come here, load that, pass input, get predictions. That's it.
So basically, inference is just only for in case testing purpose or prediction purpose.
Yes, inference itself means you are using the model. Whatever
yes.
you develop in the developing stage, okay, mostly
Yes.
you will develop what? You will develop models, right? And for this model related, you will have some supporting transformers, I mean column transforms, right? Whatever imputations, encodings, etc. Those things, development will be done over here. Whatever develop, if you want to use that, that will be done over here in the inference. So as I said, even in the practical, if it's practical also, so let's say you're working on some cloud technology, what you will do, you will take a script, let's say you're working on AWS, okay? So what it will do, you will take a, you will develop a script, okay, Python script .py file. So where it will develop, it will take the data, everything, what you're doing, it will do, and finally it will create a pipeline. Okay, this pipeline, okay, you will pickle it, okay, you will pickle it .pkl file, and you will pass it to the next team. Okay, normally it is called as this person is called platform engineer, who takes care of deployments. Okay, so you will pass them. Okay, you will just pickle this in some particular path. Okay, some path you will pickle in the sense what, just save it. Okay, for example, here what we are doing, here we are pickling in my same wherever my notebook is present, right? So there I'm pickling. Okay, so there if you can mention some path, and that path wherever this is saved, okay, you'll give that path to this particular fellow platform engineer and tell them, oh, I have already saved my pipeline over here. So what it will do, he will take this and he will deploy this in some endpoint. Okay, so in some endpoint, it's called endpoint, okay, or server, simple words. Okay, and now whenever, and this server is linked to the actual website. Okay, some, let's say, insurance website you are working for the client. Okay, now whenever a new, now let's say a new user is passing this input, okay, like this. So if he passes some input, then user does not care about all these imputations, encodings, etc., right? As we as I told you in the morning. So he will just pass the input. Okay, so once he passes this input, so this as a bunch, as a NP array, so that will be passed to my endpoint. And in this endpoint, who is sitting, my pipe is sitting, my pipeline. Okay, so it will be passed, and inside this pipe, line by line, all these functions will be executed. Okay, once the input is passed to my pipe, so line by line, all these functions will be executed. First, it will be passed through these imputations, next encodings, next column transformer, feature selections, etc. will be done. Okay, and once it is done, then you can, what you can do, the model will be fine at the last stage. Model triggering will happen, and it will give you the prediction. Okay, so once you get the prediction, that will be shown on the UI. Fine. So that is from the inference point of view. Okay. So that's about the SklearN pipelines, guys. Let me know any doubts. Understood, everybody?
Yeah, Santosh.
Okay. So next thing is, who is this? So do we need to take only 5 transformers pipeline, or we can take more? Any number of, there is no count, there is no limit, Meghana. You can take any number of transformers in a pipeline. Okay, cool. So now once this is done, okay, now once this is done, we'll see next topic. Okay, so as I said, just to give you an overview, guys. Okay, once we next concept is obviously missing values. Okay, so once we cover this missing values, okay, so it might take around 2 to 3 sessions, guys. And then there is just one concept, interesting concept called as curse of dimensionality. Okay, I think I mentioned it sometime back. Okay, it's called curse of dimensionality. That means if you increase more number of columns, if you pass more number of columns to any machine learning model, it struggles. Okay, so that we are going to see a small interesting concept. Once that is done, we are going to start with the ML model. Okay, the first model, it will be linear regression. Okay, mostly I will try to start it on day after tomorrow. Tomorrow I will try to tomorrow or day after tomorrow morning, I'll try to close this missing values concept. Okay, and post that day after tomorrow, we can close this curse of dimensionality. Okay, let me open this 1 second. Okay, so 27th morning, evening, if assuming that we are able to cover morning and evening, right? So we can cover 27 morning, evening, and 28th morning, 3 sessions for missing values, and 28th evening we can cover this curse of dimensionality, and 29th morning, yeah. So on 29th morning we can start with model. Okay, so with models, right? So we can we'll be having initially theory, and then we'll have practical application, and then for the code part, we are going to see like at least 2 to 3 data set examples. Okay, so that would be interesting. As I said, 10 ML algorithms, don't miss. Okay, so be focused with these 10 algorithms, and it will be definitely helpful. Okay, fine. So that's just a overview for the future plan. Coming back, let me start with the basic missing values concept. Okay, so see, guys, coming to missing values, as you can see, just zoom out and try to recall what all we are studying are still under this one heading called as feature engineering. Agree? In the feature engineering itself, we have studied what we are having: feature transformation, feature construction, feature selection, feature extraction, etc. Okay, and in the feature transformation itself, what all we studied, so we are having missing values, handling categorical features, outlier detection, feature scaling. Agree? So we have seen feature scaling. Okay, min max scaling, normalization. Did we see, guys, feature scaling? Yeah. Did I cover feature scaling? Yeah, I covered feature scaling. Okay, so after that, we outlier detection, I think we have already seen during statistics class. Fine. So if you remember the outliers detection in the quantiles, okay, yeah, outlier detection box plot. So you can revise this concept like 2 ways we can detect. One is using the box plot like Q1 quantiles, and second thing using the standard normal distribution, like if anything is empirical formula, etc. Okay, so you can just revise and let me know if any doubts. And handling categorical features also we have seen. Okay, how you can encode, etc. And after that, the one more important thing, but very simple and easy thing, is handling missing values, guys. Okay, now let's try to understand this. Now, but why to handle? Firstly, we need to understand why to handle missing values, because most of the machine learning models won't perform well with the missing values. Okay, So that is a point, because most of the ML models, they don't work well if you are having any missing values. Okay. So now just to tell you, there are some machine learning models, okay, which can by default handle missing values by themselves. Okay. For example, you have a model called XGBoost, okay, that can handle missing values. It can do scaling by itself, okay, it can do feature selection by itself, all what we are trying to do manually, right? So it can do by itself, okay, but it will, but the problem here is, you can just think, you can ask me, sir, if we are having a model which can do all of this by itself, why are we studying all this? Can't we directly use that model every time? No, because that will give us issues called as overfitting and underfitting. You remember some time back I explained you overfitting, underfitting. That means what? For a simple data
Yes.
set, if you use a very powerful model, then you will fall into something called as overfitting, right? So related to these, there are two other concepts called as bias and variance, okay, which I'll be covering, okay, like before I start machine learning models, okay. But I hope you remember this concept called as overfitting and underfitting. So that's why XGBoost is a very powerful algorithm. I agree that it can do all of these things, whatever we are doing, right? It can do, but you cannot use it on every simple or any other every data set. You cannot directly go and use it, okay. So, but just giving you an knowledge that there are models which can handle by themselves, okay, fine. So now, but assuming that we need to do all by ourselves, first of all, as I said, that most of the machine learning models, they expect that the data is clean, okay. They don't like, okay, in a sense that if at all your data is having any missing values, fine. So now, what are the missing, as we understood what are the missing values, how to handle this? Okay, so what is missing value? Simply, what is missing values, guys? The data set is there and some values are missing. And if you're having the question like how why there will be missing values, it could be any reasons, okay, due to some human mistake they got missed, or due while it is transferring from one system to another system, okay, due to some error, system error, they got missed, okay, or due to let's say somebody did not understand those values and they deleted, okay, or due to some corrupt files. There might be many reasons, odd reasons, okay, that could lead to the missing value scenario, okay. But now, assuming that we got a data set where we are having missing values, what are we going to do? Okay, so two main things what we can do with common sense, if we think. One is remove them or fill them. Agree? You are having missing values. Let's say a column is having, age column is having, okay, some missing values. Okay, that means what? Let's say, as I said, if you take the Titanic data sets itself, let's say you are having like 1K, that means 1,000 people, okay, 1,000 passengers, and there might be like 100 missing values. Why? Because they did not mention their age, okay, or due to some reason the records are missing for those people, okay, due to X reason, there are 100 missing values available in this column H. Okay, now what we are going to do? One simple thing is remove them. Second thing is fill them. Simple, right? But when to remove? Does removing causes any problems? Okay, when to fill and what are the different ways of fill? Now that is where the concept of missing values start. Okay, now to start with, I'll just give you an overview. If you understand this small diagram sort of thing, okay. So over here I mentioned, okay, so there are initially you can do remove or fill. Okay, filling is called imputation, guys. Okay, this terminology is important, okay, because you might be knowing the complete filling the missing values concept, but they won't ask you how you are going to fill the missing values. Okay, so they might ask you what are the imputations you have performed on your data set. Okay, this has happened to me. Okay, when I initially studying filling, I know the concept, but the question they asked was what are the imputations, but I not know this terminology. I don't understand what does imputation mean, right? So I couldn't answer. So that's why I'm telling the terminology is also important. Okay, the exact terminology like overfitting or bias, variance, okay, and underfitting or missing imputations, etc. Okay, so focus on the terminology also. So imputations, in the sense, it's called filling the missing values. Okay, and there are two ways how you can fill. Okay, one comes under univariate and second thing is a multivariate. Okay, what is this univariate and multivariate? Simple. For example, there is a did someone say something? Nothing. Okay, so let's say you are having this column and there is some missing value over here. If you are using only this column to fill up this missing value, then it's called univariate. That means what? You are considering only one column to fill the missing values. But coming to multivariate, what happens over here? okay, you are instead of considering one single column, okay, let's say this is column 1, 2, 3, 4, okay, and if at all you are having over here, okay, so there is one missing value. If you are considering multiple columns to fill this particular missing value based upon multiple column values, you are trying to fill this missing value, then that is called multivariate. That means you are using multiple columns to fill missing values. Whereas if you are using only one single column, okay, to fill the missing value, then it's called univariate. Are we good till this point?
So Santosh, I have a question. Like
Mm-hmm.
for each and every column, to fill that missing value, based on that we will do either a repeated value or average, like that we will do, right, using missing column or whatever.
Mm-hmm.
So each column, I mean, for example, if there is an age column and a salary column, so age column will be using to fill the missing values of that particular age column.
Mm-hmm. Correct.
And missing, I mean, salary is also in the same way we'll do. So
Correct.
each and everything is respective with that column itself.
Correct.
So I did not understand what is the use of here multivariant.
Okay, so yeah, for age and salary, that is simple. Okay, but in future, I will show you few examples where you need to take care of multiple columns and fill the missing value. Okay, it is not
Okay.
dependent only one column. Okay,
Okay.
so when I show you the example, you'll understand.
Sure,
Okay,
Santosh. Yeah.
so where you will consider 2, 3 columns, and based upon that, you will fill the value of this column. Okay, so let's say it is salary. Okay, salary based upon, let's say, his designation and his year of experience, you might fill this missing value.
Got it.
Okay, so like that, so there will be some dependency. Okay, I no, don't worry, I will discuss in detail when we are discussing this multivariate. Okay, fine. So now coming to this univariate, as I said, you are going to use something called a simple imputer over here to impute the values. Okay, from now I'll use the word impute, which means just fill the missing values. Okay, so here you are going to use simple imputer. So now this is a simple imputer which we are seeing, guys. Okay, so over here also you might have seen simple imputer in today's class, also morning class. You have seen column transformer where we have used simple imputer, right? So this is the one. It comes over here. Okay, it's in the univariate imputing section. Fine. So again over here, so you are going to fill the missing values. Now this column could be anything. It could be numerical column or it could be categorical column. Agree? Missing values could be anywhere. So if it is a numerical, so there are different ways. Okay, you can use a simple mean and median, or you can fill up by some random value, or you can use something called as end of the distribution. Okay, what are this? We are going to say by code. Don't worry. And if it is categorical, you can use by mode. Okay, or you can use something called as missing. Okay, what is this? I'll show you with an example. Okay, and these are the different ways how you can impute univariate, how you can perform univariate imputation. Okay, that means in simple words, okay, the words might be little fancy, okay, I would say high level, but that's in simple words, it just means we are filling the missing values. There are different ways how you can fill. If it is numerical, we are using these ways, and if it's categorical, these ways. That's it, nothing fancy. Okay, now if in the multivariate you are having two different types of imputers, one is K-NN imputer, one is iterative imputer. Okay, we are going to see once we cover these. Fine. So are we good, guys? Any doubts? Others, Meghana, Sirisha?
Fine, sir.
Okay. Okay, sir. No, sir. Okay, fine. Fine. So now let's see when we can remove the missing values actually. Okay, first we'll see this one. Okay, when in which cases we can remove the missing values actually. Okay, so only when the missing values are missing randomly, else it might mean there is some pattern. That means, let's say there is a age column, right? So somewhere over here, let's say in the 1000 rows, okay, randomly it is missing. Okay, in let's say in 101 row is missing, and 554 is missing, and 784 is missing, something like that. It's missing randomly. Fine. So then mostly you can use the removing the missing values. Okay, I mean removing that row. Okay, now in the removing in the sense what we are going to do. Okay, when I say removing, okay, for example, Yeah. So what does this mean? So if you're having this Titanic data set, okay. So if at all this age, see this age column is having missing value. So in the if you want to remove, you are going to remove this complete row. Okay. That means wherever you are having, let's say I'm having this age column, and if you filter up and if you put it on the blanks, okay. So all these rows, how many rows are there? 178. Okay. All these rows will be removed. Okay, so that means wherever this age column is having a missing value, remove that row. Like that, where you're going to remove all these rows. Okay, yeah. But the problem here is, okay, this is a method, but every method will have some advantages and disadvantages. Agree? So the problem with this missing values is, if you are going to remove, so obviously you're losing some data. Agree? So you're losing that data. That means what? So just because this age column is not having this value, you are removing this complete row. That means you are losing all this data. So you are losing this passenger ID, survived, P class, passenger class, sex column, and the fare, ticket, everything you are losing. Okay. So that means usually if there are few number of rows which are missing, okay, for example, that overall data set is having 1 lakh rows. Okay. And in that, let's say 100 rows are having missing values for a particular column. Okay, then you can remove this 100, because when compared to 1 lakh, 100 is very small number. Even if you remove this also, it's not going to affect much. Okay, compared to the ratio, then you can go ahead and remove. Okay, but if majority, if more than, let's say 20%, 30% of the records are having missing values, then you cannot directly remove them, because you are going to lose other columns information also. Then you need to use imputations. Okay, you need to impute. Okay, that we are going to see. Fine. So, but as per the concept, we need to study everything. So that's why removing is also a method. Okay, so when you are going to use, how frequently you need to use, in which cases, that we will see. Okay, but as I said, if you're having few number of missing values, then it's okay. Okay, but before removing also, you need to take care of multiple things. Okay, what are those we are going to see? Okay, so over here, okay, let's try to see. Okay, in today's class, we'll see what is a concept of removing. Okay, in tomorrow's, we'll try to understand filling. Okay, so if you talk about yeah, so you should talk about removing the columns. Okay, are you guys there with me?
Yes.
Okay, fine. So over here, if you see, I have considered this data set. Okay, this is regarding the removing. So if I want to remove, okay, assuming that I have a data set, I'm removing some rows, and what are the things we need to consider, and what will be the output? Okay, we'll try to see. Now let's say in this data set, okay, in this data set, you're having all these columns. Okay, this is my shape. Fine. And the first thing you need to go see is this one, df is my data set, is null dot sum. Okay, is null dot sum will give you the sum of missing values in any given data set for all the columns. Okay, I'm saying df is null. Okay, that means is there any null values? If at all there, how many are there? Okay, so the city column is having 0, enroll is having 0, city development is having 417 missing values, gender is having 4000 missing values, like that. These are the number of missing values, okay, in this given data set. After that, when you say mean, okay, this is a mean. That means what is a mean? Okay, for example, this is the gender is having 4508, right? Now 4508 is the sum. Okay, and what are the total number of rows? 19158. 19158. What is this? 0.235. Okay, that is a 0.235, whatever you are seeing here. That means this is a mean value of the missing. Okay, so average, on an average, like 0.23 values are missing when compared to the whole values. Okay, and when you say 0.23 in the sense, when you multiply with 123, okay, so out of the overall values, 23% of the values are missing. Okay, the count is 4000 values are missing, and the percentage values 23% of the missing. Like that, if you see df dot is null dot sum into 100, so this is a percentage, average percentage of the values that are missing in each and every column. Okay, is this clear?
Yeah, Santosh.
Okay, cool. So post that, now this is a shape. Okay, over here, what I'm trying to do here is, see, so this code will you try to understand. So what I'm doing here is, for variable, this is a simple list comprehension. Agree? This is a list comprehension. Here what I'm doing, For variable in df dot columns, if df dot variable is null dot sum dot mean is less than 0.05 and it is greater than 0, just take that variable. Simple. Even the code is lengthy. What I'm saying here is I have this mean values. Okay. So wherever this percentage is less than 0.05, okay, and it is greater than 0. Obviously, it is greater than 0. That means it is greater than 0 and less than 0.05. Wherever this percentage, I want to capture those columns. That's it. Okay. So that is what this code is doing. Okay. It is saying wherever this df dot where dot is null dot mean. Same thing. This one df dot is null dot mean. Okay. Okay. That value, wherever it is there, if that value is less than 0.05. Now, what does that mean, guys? 0.05. That means very less number of missing values are present. Agree? Only 0.05% of the values are missing for these columns. Do you agree with me or not?
Yes, Santosh.
Right? So those columns I'm considering just 0.05% of the values are only missing for this. And for every other column, it is greater than that. For example, if you see what are the city development index? City development index is what it is.
But
it is okay. Oh, it is having 2.5. Let me check 1 second. Enrolled universities to education level is 2. 0. Okay. If this is mean, this is into 100, guys. Okay. So we are checking two different things. It is not 100. Okay. This one, df dot is null dot mean. Okay. df dot is null dot mean. Okay. That means this value wherever it is less than 0.05. Okay. So wherever it is 0.05, see what all we have considered, it is city development index. Now city development index, what is this value? 0.02. It is less than 0.05. Agree? Is 0.02 is less than 0.05? Yes. Agree, guys? We're getting confused. This value, guys, this value. Okay, let me.
Yeah, Santosh, understood.
Understood? Or should I take a screenshot and show you?
No. Okay.
Okay, so from this, because in the other step, what we have done, we have multiplied with 100. Okay, so if you want to check, you should also do 100. Okay, so otherwise, if you see these values, okay, in these values, what are the values which are less than 0.05? City development index. Obviously, this value is less than 0.05. Okay, and greater than 0. I'm saying greater than 0. So obviously, these are equal to 0. These are not considered. Okay, and gender, this is greater than 0.05. 0.2 is greater than 0.05. This is 0, not considered. Okay, and enroll university. This is also less than 0.05. And education level less than 0.05. But major discipline, this is 0.1. This is greater than 0.05. So it is not considered like that. Clear?
That is greater than 0, it should consider, right, Santosh?
But greater than 0 and less than 0.05, right? Which one you are saying?
Okay, I mean,
Which one? Major discipline?
0.14.
0.14 is not less than 0.05.
0.05. Yeah. Okay. Yeah.
Okay. So only in between 0 and 0.05, in other words.
Yes.
Okay. See, company type, this is also 0.3, greater than 0.05.
Correct. So we have got city development is enrollment.
Training hours. If you say training hours,
Training
0.03. Yeah.
Yes.
Okay. These four we got. Okay. So because the value is very less, as I said, there are only few number of missing values. We can remove this. That's why I use this percentage. For others, for example, if you see, okay, in multiples of 100, it is easy to understand. For example, if you see gender, it is 23% of the values are missing. So you cannot directly remove all those rows. Getting? Because you will lose lot of data. 23% of the rows will lose. And also major discipline, 14% of the values are missing. You cannot remove. Company size, company type, there are many values missing. You cannot remove. Agree? So that's why only where there are very few missing values are there, I'm considering only those so that I can remove. Getting? Meghana, are you on track?
Can you please repeat one, Santosh? Last point.
Yeah, I'm saying See, why I'm considering this? I'm considering this so that I can remove certain rows. Okay, now here only if there are very few number of missing values, only then it is easy, it is okay to remove. That's why I'm considering this percentage. That means the missing values are very, very less. That means just 5%. 0.05 means what? 5%. Okay. So that's why I'm considering only those columns which are having less than 5% of missing values. If it is greater than 5%, I'm not considering, because, for example, if you see gender, this is having 23% of missing values. That means there are so many missing values. I cannot use remove method. Okay, I cannot use this remove method. I should use this impute method. I should fill.
Yeah, because
Yeah.
okay, because if you remove less percentage of columns, if you consider, so then there will be chance of removing less records orally.
Correct.
Okay. Got
But
it,
if this major discipline is having 14% of the missing values. So if I remove 14%, that means few thousands of records. So obviously I'm losing so much of data. So I'll
Yes,
not
yes.
do that. So that's why I'm not considering this value.
Okay.
Okay. So that's why I'm putting only less than 5%. So I will have only these 4. Okay. So I will remove only few columns. For these greater than 5%, I will use some imputations that we'll see later. Getting?
Yes, Santosh.
Yes, sir. Okay, fine. So when I got these 4 columns, and these are my columns. Okay, so 1, 2, 3, 4, 5. So these 5 columns are am considered. Okay, these 5 columns are these 5 columns. Okay, and after that, certain value counts I'm seeing. Okay, now the point here is if you just say drop NA. Okay, now on this DF columns, I'm just doing drop NA. That means just drop all the rows wherever you are having a missing value. Okay, that means any row, even if it is having one single missing value, it will just drop that row, guys. Okay, so that means over here you are having this. Even if, let's say, assume a row wherever you are, let's say only this single value is missing, then it will drop the complete row like that. For example, if you see this NaN, that means it is a missing value, then it will drop this complete row. Okay, like that, when you are specifying drop NA, it is going to drop the complete rows. Okay.
So in any one column.
Yeah, even if any one column is having missing also, it will remove. If it's having more than one column, anyhow it will remove. But even if it is having one column missing value also, then also it will remove the whole row.
I mean, whole row of complete data set.
Complete data set, yeah.
See, because now you have taken calls, I mean, DF of calls, I mean, that is only having 5 columns.
Yeah, in the sense, this is only from this data set only. Okay, forget about other columns. So I'm considering only one single, this small data set, DF. Okay. So from this data set, it will review, if at all, if there is a missing value is there, it will remove this complete row. You lose the values of other also. Okay. But if you consider from the actual data set, from there also it will remove the complete. Okay. For example, even if you are considering other rows also, from there also it will remove the complete row. Okay. For example, this row is there. Okay. As I said, this row. So it will remove this complete row. Getting?
Yes.
Okay. Fine. So
at that time we have to use DF of complete data set name instead of calls. I mean, in this case.
Correct.
Whatever the data set that we need to, yeah. Got it, Santosh.
Right. So, and yeah, so that is, see, now this is my drop NA. Drop NA is, it is dropping the values. And once you have dropped it, okay, now what is the length that you got? So that you got, that is 89. That means what? Earlier, if you're having 100 records, after dropping the records, you are having 89 records. The percent is 89. That means around 11% of the records rows are dropped. Okay. Around 11% of the rows are dropped. That means what? In different scenarios, like for example, from this 11%, okay, 11% of the rows are dropped. Okay, now see guys, here the point here is, now what is 11% of the total rows are 19158. Okay, 19158 into 11%. How many? 2000 rows are dropped. Okay, 2000 rows are dropped. In this 2000 rows, okay, in some rows, it might be because of city development. Wherever city, let's say some 400 rows, the city development is having null values. So it will remove all those rows. In, let's say, some 200 rows, it is because of this enrolled university. It will remove all those. In some other, it will have educational level. In some other rows, experience. In some other, training. So like that combined overall, it has removed 2000 rows. Getting? No? Okay, fine, guys. I would say it's okay. I would say it might take it might take
Yeah,
a bit lengthy. Okay, I understood. So tomorrow we can cover, no issues. Okay, because I need to cover multiple things. I need to show the distributions, etc. Okay, so time may not be sufficient because we already covered another concept. Okay, so fine. Tomorrow with the fresh mind we will have a recap and we will cover these also. Okay. Okay, fine, guys. Thank you.
yeah. Thank you.